My name is Vipul and I have 11 years of IT experience. During my IT experience, I have worked on multiple tools. So I started my journey from the Informatica data migration tool and then I moved on to the SAP world. In that I worked on SAP Data Services, which is again a data migration tool which is specific to SAP. And then I worked on SAP HANA 2.0 on-premise as well as SAP HANA on cloud. And after that, I worked on SAP Analytics Cloud, which is a reporting tool available by SAP. And it has a lot of great features available to us. And then after working in those technologies, I moved on to the Snowflake Data Warehouse and also MySQL. Apart from that, I'm also associated with Data Vision as a trainer for MySQL and Snowflake Data Warehouse. So let's get started. Okay. So if it is all good, then we will progress with the next topic for today. So we are pretty much done with the very important concepts of data warehouses. So today we will start with the concepts of clouds. So even if you look at the curriculum of Snowflake Data Warehouse, they assume that you know about the cloud concepts and your data warehousing concepts. Okay. So that is why it is prerequisite for our course as well. So we will also go the same way. So first of all, before starting the Snowflake Data Warehouse, we will also understand how the things work, how the things evolved, and how it is now. Um, because just looking at the current picture, it will not be able to very helpful to us to understand how we got here. But if we understand how the things progressed, how things evolved from what they were to what they are now, it will not just help us to understand how things are working right now, how every component grew, how they are connected to each other, but that will also help us understand how things are going to evolve. So we will understand the pattern of how things evolved, and looking at the current scenario, we will also be able to understand where the things are going. Okay. So these are the two important things we will try to understand. Okay. Okay. So now we know that there is something called as cloud terminology. There is a lot of um, um, there is a broad use of this term. What is cloud? There is a cloud technologies, there are cloud terminologies, IaaS, PaaS, there are a lot of tools which are in cloud and so on. So you will be hearing this word a lot, okay? I remember I heard this word somewhere 10 years back or even more than that. At that time, it was not that much used, but yeah, I heard this word somewhere around 10 to 12 years ago. Okay. So this is over there. Okay. So, um, so we will understand what is cloud, why everyone is going to cloud, why most of the uh, tools and softwares we have these days, they are cloud based, and what is the problem? What was the problem with the previously existing architecture? Okay. Okay, so I mentioned it had the cloud concepts. Okay, so but before going to the cloud concepts, we want to understand something that the opposite of cloud concept or the cloud terminology is on-premise technology. Okay, so before the cloud concepts was there, everything used to be something called as on-premise. Okay, so on-premise, I will write it at two places. At one place, I will mention on-premise, at in one place, I will say cloud, okay, cloud terminology or cloud. Okay, so I'll repeat, the opposite of cloud is on-premise. It was called on-premise because all the hardware, all the networking, and all the infrastructure used to be in the premises of the clients. Everything was managed by the client, everything was maintained by the client. So that is what it used to be. Okay, we will go into a very good detail about that. Okay, so the management, the maintenance, everything was client's responsibility. Okay, a client as in the person who has set up the organization. So instead of client, I can say the organization's responsibility. Okay, so in case if you have visited your office, I mean, it has been long time. We are working from home. So if you have gone to your office, then you might have seen that there is something called as server rooms. So server rooms are something where all the hardwares are kept together and all the hardware components, whether they are your systems, everything having the hardware, network capability, and storage capability, everything was kept over there. And because servers have emit a lot of heat, and even you can look at your laptop. Your laptop also emits heat. So all these hardware emit a lot of heat, and because if the hardware is very high performance hardware and it is performing at a very high speed and perform doing a lot of calculations, then the server is going to emit more heat. So it made a sense for the clients or the organizations to have a separate room for the servers, okay, so that they can be kept in a cool room, and the those rooms are generally air conditioned to make sure that machines remain cool and there is no problem of heating us or sparking or something like that. Okay. So we had something called as server rooms. Okay. Whereas if you look at the cloud, we have given all the headache of management, maintenance to some other vendor. Okay. That vendor can be, we have different cloud providers. The biggest cloud providers are AWS, that is Amazon Web Services. We have GCP, which is Google Cloud Platform. And similarly, we have the Azure from Microsoft. We do have a lot more, but yeah, these are the major players. Okay. AWS came in the market in somewhere around 2006. So it is the oldest, it is the market leader, and Azure came somewhere around in 2010, and GCP came very late in the market. And if you talk about AWS, because AWS came in 2000, I mean, it didn't come publicly in 2006, but yeah, it was launched internally in the Amazon Web Services in 2006. Then it later on grew, and in somewhere around 2008, it went public. In the very initial stages, they were having very less services, but right now there are more than 250 services which are available at by AWS. Okay. And it also has its own learning skills. It has a lot of depth and breadth and a lot of different terminologies, technologies, and very latest technology like your uh, modeling concepts are there, your data warehousing concepts are there as well, your networking concepts, your hardware concepts, everything is covered in AWS. Okay. So it's a entire word in its own and has its own set of service certifications. Okay. Okay. So what cloud services does, so we will go into the depth. So these are all the very high level basics which I wanted you to understand. And one thing which you want to understand is that whenever I talk about cloud concepts or cloud software or cloud technology and everything is accessed using your browser. Okay. So this you have to remember. Okay. And because security is very much important, because everything is accessed through internet, so security is very important. Okay, security is paramount. I mean, security was also paramount in the cloud concepts I mean, in the on-premises. So it is, I mean, this is something we will mention over here because if a client is going from the on-premise to cloud, then they will for sure have to have the highest level of security. Okay, because the organization is moving their data from one place to another place. Okay. Okay. So now let us go forward and go ahead with the PPT. So because everything is accessed over the internet, over the browser, using the browser. So that is why we will just very briefly understand the different concepts we have. Okay. We will start from very basic. So this is what I wanted to do, so that is just in case someone is not aware of that any concept, so that this is a refresher for them as well. Okay, so let's get started. So because we are working in a cloud terminology or a cloud concepts, we have to understand very basics of how a website work. Okay, so the client is your machine. So you are trying to access the internet. So we are also we are all right now connected through the internet. Okay, and server is where our recordings are getting saved and where the common your Zoom application is installed. So everyone, each one of us are connected through the internet to the Zoom applications, and the Zoom application is not just providing us the live interactive session, whereas it is also saving the recording as well. Okay. So one server, so this server is hosting the data vision app. Okay, you can say that way. So the client, so these are the main three components we have whenever we are talking about the websites. So we connect to a server and the server provides services and we are connected through the network. And just like we have cars and each car has its own identifier, each home has its identifier, Just like that, whenever we are on the internet, each of the component we are talking about in the internet is going to have a unique identifier, and the unique identifier for each and every object in the internet is going to have the IP addresses. So we have two type of IP addresses. We have IPv4, IPv6. Actually, the IPv4 addresses are limited and they are going to exhaust very soon. So that is why we have IPv6, which has a lot of different ranges. Okay, it has a very high range. Okay, so not going to into that. So this is just an identifier of any entity which is available on the internet, whether they are providing the services or they are taking the services. Okay, so someone who is taking the services is called client, and someone who is providing the services is called a server. Okay, in the internet we can also have two clients talking to each other as well. That is peer-to-peer. But right now, this is for the simplicity sake, we are talking about the cloud client service architecture. Okay. So now if we talk about the server, so a server will have different components. So the server will have a CPU and server will have a RAM, because the server is going to serve something, it is going to provide a service, as you can say. So it is going to use some memory, it has to compute some resources, and it has to it will have to process the data which is given by the client and then return the results as well. So that is why a server will have a CPU and RAM. The combination of CPU RAM, you can consider it to be a brain, because our brain works like that. Our brain processes something and it has a storage as well inside of it. And then apart from that, the server also needs storage. So because RAM is not persistent, some persistent storage is also required, and that is provided as well in the server as well. Whether it could be a database, whether it could be a file, whether it could be any format we want to save the data in. Okay, but we need a persistent storage. Then finally, if we are not storing the data in terms of files, then we will have to have a database so that we can store the data that is coming on our way, and we can process it and then we can return the result. So we might need a database in our server as well so that we can store the data in a tables as well. Okay. And then we have different network components, hardware components. If we talk about, we have routers, we have switch, we have DNS server, and so on. So let us talk about the different terms we have within the cloud terminologies. So here you can see that this is a bit of a diagram as opposed to the first one. So here we can see that this is a client to client or peer to peer internet connection. So here we can see that there is one client which is connected to the router, and then we have a switch, and then there are multiple clients which are connected to one switch. Okay, so this is one network. So all in all, this diagram you can see here, there's a network, and here you can see that network consists of cables, it consists of routers, it consists of servers, it consists of switches, and it consists of multiple different components as well. So we have something called as router. So router in, if I just say whatever it is written over here, so a router is a networking device that forwards data packets between computer networks. Okay, and they know where to send your packets on the internet. We will not go into very detailed of how the router works or how the switch works. This is just an overview session. So, and the other thing we have is switch, which takes the packet and sends it to the correct server or client on your network. You can consider it to be, let us say this, the client, which is over here, which is sitting single, which is not in the as a part of this group. So this person is trying to send an email or trying to send an address to this computer or this computer or this computer, to a specific computer. So you can consider it to be a terminology when we used to post the letter. So it is just like that. So in this case, this is your local post office, and the router will be the state post office, which is going to have the data, which is going to forward your letter from one state to another state. And then this is again your local post office. So let us say if I am trying to post a letter, so first of all, I'll have to drop it within my city's post office, or within there were post offices right near your home, which were red colors, and then we used to post the letter over there. And then the postman used to come there and used to collect all the letters from different post offices or post box, and then they used to gather everything in their state level of the post office. So we had post office for each and every city, and then for each and every state. So they used to merge everything in one place. And routers is like you can have your letters of a state level. Okay. So let us say if someone is sending a letter from Bengaluru to, let us say, to Bhubaneswar, maybe. So there will be multiple post offices. So all the letters from, let us say, Bengaluru will be collected in one place, and then all the letters which are destined to be sent to to your Kolkata, or let us say any other city. So they will be grouped together and they will be sent from one main post office to another main post office. So your main state level post office will be your routers. And then once they reach the destination main post office, then they will have to be separated to each and every area level, or the locality level, so that the routers then at the destination, all of the letters will be taken from the main post office, and they were then given to the local post office. Here you can see that based on the locality. And then based on that, the postman used to take the letters and then distribute it to each and every home. Okay. So the routers you can have very well understand to be the main post office or the state level post offices, and the switch you can consider it to be the local area post offices, which all different districts we have, different localities we have, and based on that they were distributed to each and every step. Similarly, we have the same terminology over here, and that is how you can see her here. And then if you go more detailed about that, so here, that is all about it. And now let us say that hey, you might have heard that most of the big companies like Google, or I mean, there are a lot of companies, even Microsoft is there. They all started working in a garage. So let us see how they actually evolved from there. So that even if we can consider our case, let us say we are going to start an organization, and to start an organization, we have to have this setup as well. Okay, we need a server. Here you can see that we need a server from where we can host our applications, or we can host our websites. Okay, so if I want to host something, I have to have an application which is installed and which is deployed on the server, and then that server will provide the different capabilities. Okay, so what I will do, I have started a very small business and I have started the website, or I am providing a service over the website. Let us say I have started providing a different services, can be let us say very small supermarket I have started, and I am delivering stuffs over online, and I have my website, and over there I am taking the orders and people are just sending orders, and then I am delivering it to their home. A very small business which you have already seen. Okay. So now here you can see that I am keeping the server in my home or in my garage because it is a very small website, and I am fine with one server in my home. And then as the demand grows, people are liking my website, and I might need more resources from my side, because if the what you can say, if the demand is increasing, so my server should become more and more powerful, because the server setup I had previously is not enough to serve all the different requests which are coming forward. So that is why either I increase the capacity or the strength of my server, or I increase the number of servers. So here you can see that as the demand is growing, I am increasing the number of servers in my home, so that to accommodate the growing demand. Okay, that's fine. But let's say the demand is growing more than that. So that is where the problem is coming, that I will not be able to have all the different servers in my home or in my garage. I will have to rent a space for that. And again, what I can do is that I can rent some space in one of the office. I will borrow one storage space, or a single room or a floor over there. And in that floor, I will keep piling my hardwares over here. So here what you can see is that I have now set up all the servers required for my website in an office space. Okay, so I have rented a space in the office, and I have kept all the different servers in one place. So that is where we have concepts like it's called as data centers. In the data centers, we have different servers which are working together. They can be hosting my website, they will be having databases, they will be having different components, all the components which are required to provide the service to different users who are trying to connect to my system. Okay. So here you can see that we have data centers. So in the data centers, we will have all the different components. So you will have hardwares, not just hardwares, you will also have to connect different machines within your data center and so on. So in the data center, you can consider it to be different servers which are kept together, and they are connected to each other. They are provided with the power supply, they are provided with the proper air conditioning, and everything is provided to them so that the servers can be run over there. Okay. Within the data center, for the data center, because there are a lot of servers and I might need some upgrade capabilities, so there will be a dedicated team which I will have in my office who will take care of the maintenance and management of the different servers. If the upgrade is required, if a maintenance is required, if I am planning to increase the bandwidth of my different servers, so I will also do that over there. Okay, that is all. And now if we talk about the next topic. So here you can see that we let us understand what was the problem with this traditional architecture we had. Okay, so if we consider the data center, here let us check about the different problems we will face using this infrastructure. What was the problem with that? So first of all, we had to pay for the data center because all the server are available in the rented place because they are on not no more available in my home. So they will be so I will have to pay for the rent for that. And again because there are a lot of servers which are running in my infrastructure in the data center. So I will have to pay for the power supply, the cooling maintenance, and so on because there are servers, right? They are going to run on a power, and I will also have to provide the air conditioning so that there is no problem with that. And again, the adding and replacing the hardware will take time because if you want to add a hardware, you will have to go outside, you will have to buy it, and then you will have to install it, and that will take a lot of time. Okay. Even if I am starting to build the data center, it is a pain because there, let us say, if you want to buy a server, so you cannot just buy it like that. You have to go outside. You have to just like that. Even if you are buying a laptop, you have to go to the market. You will have to do the research, which server is good, how much hardware you need. This is also one thing which you have to consider. Whether I need a 20 GB RAM or it is not going to be 20. It is in multiplication of 2. So whether I want 20 GB RAM, let us say, whether I want 20 GB RAM, whether I want 40 GB RAM, or how much hardware I will be fine to host my application, whether it should be 100 GB, 200 GB, 1 TB. So first of all, you will have to decide how much hardware you actually need, and then you will have to go out there. You will have to check different vendors, whether you should go with HP, you should go with Lee. There are a lot of brands. Okay, Acer, and all these different hardwares, and then you will have to see the pricing comparisons. So which price is fitting your budgets, and then finally you will make up your mind, and then you will bring that hardware and you will do the setup. Okay. So this concept is going to take a lot of time if you are trying to start a business today. So you will have to plan it in advance, and then you will have to think about how much capacity you need, and based on that, you will have to do the research and buy that hardware. That is why here you can see that adding and replacing hardware takes a lot of time. And again, the scaling is limited because here, first of all, I had started this infrastructure setup in my home. Let us say in my home, at most I can have 3 servers or 4 servers. Okay, but after the 4 servers, I will have to ship them from somewhere else to some other place so that I can accommodate for more hardware. Again, offices are going to have a constraint because there will be always a hardware constraint. In the office space as well, I can add 50 servers, I can have 20 servers, but there is going to be a limited resources to which I can expand. So here you can see that the scaling is limited. And then again, as we have already discussed, I will have to hire a 24/7 team to monitor the infrastructure. And then what about the disaster? Let us say I have set up a data center either in my home or in the office and something goes wrong. There is an earthquake, there is a fire, a breakout, or there is a sparking issue, or something happened, or maybe the shutdown is there, or there is a power supply issue. Then how do I deal with that? So I will have to check for that, how I make sure that the website is always up and the users have the uninterrupted experience. So that strategy, I will have to do that. So here you can see that there is a lot of additional amounts or different prices I have to pay. So is there someone who can take care of all of this hardware? Is there someone who can provide the data center, who can pay for all these things, who can add or replace the hardware for me, who can provide me the scaling, who can provide me the team who is working 24/7, and who has this architecture available so that I have the resilience architecture in my offices. so that if something goes wrong in the hardware, I always have my application or my website available all the time. So that is the question. Can we externalize all of this? Yes, the answer is the cloud computing. Okay. Okay. So if I go with, so right now you can see only AWS is mentioned because they are major players. It is not specific to AWS, but whatever concepts we are going to understand today, they are specific to Azure as well as the GCP as well. Okay. So what is cloud computing? Very basic thing. So the cloud computing is the on-demand delivery of compute power, database storage, applications, and other IT resources. Okay. So before we had to go outside, we have to purchase the hardware, we had to install them, we had to maintain them, we had to manage them. But right now in the cloud computing, you can say that everything is available on demand delivery. Okay, whether you want to have some compute power, you have to have a specific processing power required. You want to have some specific storage required. You have some application needed. So you are provided as an on-demand. You do not have to go anywhere. You don't have to do any research. You do not have to wait a long time for that hardware to be delivered to your home. So everything is provided on demand. Okay. So, through a cloud provider services, we have something called as pay as you go. So, if you use some hardware, you will pay for that. And if you are not using some specific hardware or services, then you will not pay for that. Okay, which is in very contrast to your traditional approach. In the traditional approach, you can see that, let us say you have set up a data center, you have 10 servers, and in 10 servers, you are hosting your application or your website, but you really do not need that much of capability. Maybe the demand also fluctuates. Let us say in a specific period, let us say during sales or during the festival season, the demand is very high. And during the other periods, the demand is very low. So we cannot scale up or scale down our data center. So if I have set up the 15 servers in my data center, all the servers should always be running irrespective of how much demand is coming. I can switch off some servers, but again, it is going to take a lot of time. If, let us say, the demand suddenly increases or suddenly decreases, then it is going to be a nightmare for me because the server will take a time to boot up and I have the connection and everything to be set up and to go live with the additional hardware or additional resources. So here you can see that that is a very good thing we have with the cloud services. If we need more storage, if we need more power, we can have it on demand delivered to us and we pay for whatever is being used and we do not pay for whatever we do not want to use. Okay. And then you can provision exactly the right type and size of compute resources you need. If you need more hardware, you can scale up. If you need less hardware, you can scale down. And if you need 12 GB of RAM, that's fine. If you need 20 GB of RAM, that is also perfect. If you need 100 GB of RAM, that is also available from the cloud services. So there is no limitation, there is no hardware limitation, which is available to you. So you can provision the right type of size of the computer resources. If on the next month you want to scale down from 20 GB to 10 GB, that is also possible. Okay. So you do not have to worry about what is going to happen with the hardware which I have already purchased. You do not have to necessarily take care of them either if they are serving no purpose. Okay. So now the next thing is that you can access many resources as you need almost instantly. Okay, so everything is delivered on demand and everything is available instantly. And again, we have a simple way to access the servers, storage, databases, and a set of application services. So previously, when we were talking about the on-premise architecture, so we have to had a different type of, we had to prepare different firewall settings. We had to take care of all the security concepts, all the different ways to access it, whether you can access it through a system or through a specific software. Let us say if you are developing an app and your website or your website and your website can be viewed only in specific browser because you have not tested it other browser. So you had to think, okay, let us say if a user is having very bad experience, so I have to develop an app so that users can access it on their mobile phone. Again, you will have to develop another app to make sure that your iOS users can also access it. Then you have to develop your website as per your different operating systems. Okay. Right now we have different languages, I understand, which are very compatible among different hardwares or among different softwares. But still, you will have to go with a different development language, which is suited for that specific operating system. So, but because everything is accessed using the browser in the cloud computing, so it is very easy to access just in case if you want to connect to your servers, if you want to scale up, scale down, or if you want to consider what is going on in your database, in your storage level, then you have to access it using your browser only. Okay. We are talking about AWS, but the last sentence is also applicable to the different cloud providers such as GCP and Azure. So here we are trying to say that the AWS or any cloud service provider, they own and maintain the network connected hardware required for these application services while you provision and you need for your web application. So these cloud providers have a really large pool of services and different large pool of hardwares available to them. And if you need something, you can provision a chunk of that information. So you can consider that they have, let us say, 100 GB of RAM and they have 100 TB of storage available in one place. And if you want a chunk of it, if you want 2 GB of RAM, you can take it from them. If later on you want 4 GB of RAM, you can provision from them. So now here you can see that the next thing is now. So this is where you can see the difference between the office and the cloud. Okay. Thank you. So this is the comparison on Office and on the cloud. Whereas in the Office, all the setup has to be done by me. Whereas on the cloud, everything is available to me. I can do almost a very good flexible work. Okay. So we will see when we will go to the AWS section. So we will really appreciate how we can so easily scale up and scale down and provision the different services and applications. So here you can see that we have already been using these cloud services, although we do not recognize that. So here you can see that we have Gmail. We are using the Gmail services. We are using the different mails, and we just focus on the work. We do not care about um, where our mails are going to be stored, in which language email is written, where it is going to storage, which location it is going to be, how it is being optimized. All the things are out of our mind, and we just focus on using the application. Similarly, for the Dropbox, we can place our files, we can access the files, we can share the files, irrespective of without even knowing where they are stored. And if I want to scale up, if I want to store large files, I can do that. And if I want storage less than that, I can also do that. Again, we have Netflix, which is a video on demand services. We do not know where the movies are stored, how they are compressed, how they are transferred to us. And I can watch movies on top of that. So here you can see that the Netflix was also built on AWS. Okay. So we have been using these different cloud services without knowing that. Okay. Okay. So now here you can see that we have different deployment models in the cloud. So here we have the private cloud, we have public cloud, and we have the hybrid cloud. Okay. So I will first of all give you a terminology of these different cloud concepts using the ride sharing app. Okay. So okay. So first of all, let me go back and let us understand about these different things. Okay. Okay. This one. Okay. So on premises, if I take the car terminologies to help you understand what is going on here. So on premise is just like owning a car. Okay. Owning a car. So here, just like on-premise, if you want to own a car, you will have to do a lot of research. If you make a decision today, that, okay, I want to buy a car. Maybe you want to buy a car to drop people from some place to another place, or if you want to buy a car to give it to someone else, or if you want to rent it to another company. So whatever the purpose is, but you want to own a car. Okay, you have to buy it. So again, you have to first of all decide what type of car you actually need, whether it should be a sports car, whether it should be a sedan, whether it should be a family car, whether it should accommodate 7 people, 5 people, 4 people, what type of car it should be, whether it should be fuel, whether it should be electric car, and again in fuel you have to decide whether you want the petrol car or diesel car. You have to make a lot of decisions, and then you have to decide what type of engine you want. You okay with the V4, V6, V12? If you want a very good vehicle, you can also go with V12, but it is going to cost you a lot. And then you will have to decide what color of your car should be, whether it should be golden, whether it should be white, whether it should be black, whether it should be olive green. So you have to make all the decision. And then again, you will have to go to different companies. You will have to go to Kia, you will have to go to Mercedes-Benz, you will have to go to BMW, and then you will have, there are a lot of vendors. You can also go to Morris Garages, for instance. So you will go there, you will talk to them. Okay, this is the car I need. This is the purpose it is. What is the mileage you are providing? Whether you have this color or not. And if you're super rich, you will go to Lamborghini, you will go to Rolls Royce, you will get to Maybach to buy your car, and then you will do a test drive as well, so that you can actually see and feel how the driving looks like. And then finally, after taking a lot of time, maybe taking maybe 6 weeks or 1 month, you will actually decide which car you actually want to purchase. Okay. So now you have owned the car, and again, there is a price associated to a car, so you have to pay for that. Either you can pay upfront or you can pay in EMI, okay? And then everything is your responsibility. If you are owning a car, if you are going with EMI, the loan will be on your name. Okay, so everything is your responsibility. You have done all the research, you have done all the requirements, you have checked it, you have done the test drive, and you have bought the car, and you will pay for that, no matter which way possible. And then once you have owned the car, then if, let us say, God forbid, if something goes wrong, if the headlight is not working fine after a few days, or let us say after the warranty period, if the wipers are not working, if the tail light is not working, if there is some problem with the engine, then it is your responsibility to take the car to the owner or the different service center and to get it fixed. Okay, this is all your responsibility. Just like in the on-premises, everything was your responsibility. Okay. Now you will see that, okay, can I externalize this? Can I have someone else working for me? Then you have something called as cloud. Whereas in the cloud, you can consider cloud to be, let me paste it. So you can say to be a ride sharing app, ride sharing. Okay. So now if you look at the terminology of cloud, you can consider it to be Ola, you can consider it to be Uber, where you are not owning a car, but you are using a service which is provided to you, and based on your requirement, you can use the car without owning it. Okay. So you're not owning a car over here. Okay. You are just paying for the service. So let us say if you want to go from location A to location B, you do not have to worry about what type of car it is, what is the color of that car, whether the driver is having the license or not, whether the driver is professional or not, whether the pollution checks are done for that car or not. All the services, all the things are out of your head now. It is the sole responsibility of Ola or Uber, in whichever case, to make sure that all the standards are met, everything is fine, all the services are working fine, and you just care about the associated cost, about the comfort, and these are all, and maybe the time as well. Okay. Just in case if you want to reach from one place to another place in a specific time period, then you will have, okay, our driver, do it fast, please ride fast, I want to reach there in 10 minutes. So time is your constraint. You will be comfortable because you do not want to be in a very discomfort situation while sitting on a seats of the car. So yes, and again, cost is your uh, primary thing. So based on the cost, if you want to take someone special with yourselves, then you will make sure that, okay, I will go with a sedan or I will go with a very high tier car. But if you are alone traveling from some one place to another place, you will consider a mini cab, or even you can go with a bike as well. Okay. So there you will take care of the cost based on your budget. Okay. So this is how you can really well compare the on-premise and the cloud. Within the cloud, again, which we have seen, we have different cloud deployment models. Let us talk about the deployment models. Okay, deployment models. So we have the private cloud. Okay, in the private cloud, again, the car is not owned by me, but at the same time, it will not be used by someone else. Okay, Let us consider, okay, in the Ola as well, we have a service where we can rent a car for a specific duration. Okay. So let us say I have rented a car for, let us say, for the next 2 hours. Okay. No matter whether I use it for 2 hours or not, whether I go from one place to another place and I park the car somewhere, or let us say, even if I use it for 1 hour, nobody else is going to use that car for any other purposes. Although it is publicly available, but for these 2 hours, the car is mine and I can drive it just like my own car. Okay. So that is the terminology we have within the private cloud. So here the cloud services used are used by a single organization and they are not exposed to the public. So they, although these services are available in the cloud, but they are private to me. Okay. So we have the complete control. So if you look over here, so I have complete control over car. I can take it anywhere else I want as soon as the roads are fine. Okay. I can take it anywhere, and then security for sensitive applications, and then if I have specific needs, I can have it over as well. Okay, so these are my private cloud. So if I talk about the public cloud, so public cloud is anyhow, if I'm using any ride sharing cab or a ride sharing service at that time, I if I want to go from one location or the other location, and that will be done within 30 minutes. Within that 30 minutes, you also can have ride sharing. Multiple people can travel with you. Multiple people can sit within the same car with you and you can do the ride sharing. And as long as you are sharing the same space, you are having the public deployment model. Okay. So if you look at the public cloud, so the cloud resources are owned and operated by a third party, which is all in this case, and then they are delivered on the internet. Okay. So we will also understand the 6 advantages of cloud computing. And finally, we have something called as hybrid cloud. I will mention it over here because it is somewhere between your on-premise and cloud. So we have hybrid cloud. Okay. So here you can see that, okay, I do not want to go with this model. I'm not fine with that. And I'm not I don't want to go with 100% this. Okay. So here you can see that, so there are some companies who have been working in the on-premise model for a very long time. It is going to be very difficult for them to quickly switch to cloud. Okay, because they will think about how the data will be there, whether it will be secure or not, whether it will be available or not, or what all services we are providing, whether they are available on the cloud or not. Okay, so now it will be very difficult for them to switch from one service to another service. Okay, so that is why the cloud providers have provided something called as hybrid, where they can use the on-premise capabilities as well as they can use the cloud models as well. So now let us take again the example of a car. So let us say I have owned a car for a very long time and I do not think that whether Ola services is actually good for me or not. So what I will do, I will own a car, and also let us say I have a Ola app installed on my phone. Let us say my car is not working fine. It is having very low fuel in that. So in that case, I will say, okay, I will go with Ola. Or I can have a different strategy. I will say that, okay, if I have to travel more than 10 kilometers, only then I will use my car. But if I am traveling less than 10 kilometers, if I'm going to a nearby restaurant or if I'm going to nearby cafe, then I will use the Ola cab. Okay. So this way, what you can do is what you are doing is that you are having the hybrid approach. If the need comes, then you will use your own car, or if you are going to your office, or if you are taking some special family member with you, then you will prefer going to go in your own car, so that you can have your private moment and you can also enjoy your time and you have your own privacy in your place. Okay. But whereas if you are going again, you are going alone, or if you are going with someone else to the office, and then it is fine. If there is no private conversation going on, then you can consider going to with the cloud terminology as well. So here you have what the cloud hybrid technologies we have. Here you can see that we can keep some servers on premise and extend some capabilities on the cloud. So if you do not want to go straight away to the hybrid to the cloud terminologies, you can use both the things as you please. And you have control over sensitive assets in your private cloud, whereas you have the flexibility and cloud effectiveness of the public cloud. So you are taking the benefits of both the different scenarios we have over here in the hybrid cloud. Again, if we look at the different cloud providers, so for the private cloud, we have Rackspace. For public cloud, we have GCP, AWS, and Azure. These are the major players. And then finally, we have the hybrid cloud where we are working somewhere between the on-premises and the cloud services. Okay. So now, first of all, let us understand about the five characteristics of the cloud computing, which we are also seeing till now. So here we have the on-demand self-services. So the users can provision the resources and use them without human interaction for the service provider. So we will see in the AWS sessions going forward that if you want to provision a hardware, if you want to provision any service, you do not actually have to call the AWS team. You just go to their website and you can provision them on your own. If you want to scale up, you can do that from their website. If you want to scale down, you can do that as well. So there is no human interaction to get this service available to you. And then we have a broad network access. So the resources are available over the network and can be accessed by diverse client platforms, okay, which we have already discussed. And then we have something called as multi-tenancy and resource pooling. So again, the same thing which we were talking about, the ride sharing apps. So there could be multiple people who are traveling with you in a same car, and everyone wants to go to a different destination. So here you can see that multiple customer can share the same infrastructure and application with security and privacy, and multiple customers are serviced from the same physical source. So multiple people are traveling in the same car, so the hardware is same, and they are going to their own destination, and they're sharing the journey in the same car, and they have their complete privacy. Okay. Again, we have rapid elasticity and scalability. So we have automatically and quickly acquire and dispose resources whenever we need. So if the demand is more, we can ask for more hardware. If the demand is less, we can then go for less hardware as well. And we can quickly and easily scale based on the demand. We will see that again in the AWS sessions. And we have a measured service. Okay. So the usage is measured. The users pay correctly for what they have used, and they do not pay for whatever they have not used. Okay. So and then the next topic we have. So now let us talk about the six advantages of cloud computing. Okay, so we had mentioned it over here, the six advantages of cloud computing, and then let us talk about the six advantages of cloud computing. Okay, so first point we have is the trade capital expenses for operational expenses. What is operational expenses? First thing, so operational expenses is the different things we had to pay when we were hosting everything in our own on-premise, or we were taking care of everything. There were a lot of operational expenses which were associated to it, whether we had to hire a team, whether we had to buy new hardware, whether we want to upgrade something, whether you want to pay for the rent for your storage, whether you want to pay for electricity. There were a lot of operational expenses because we had to have a lot of expenses for which we had to pay to make sure that our operations are working fine. Okay, that is operational expenses. Whereas the operational expenses are almost negligible because if you are having the cloud service provider or if you are taking the hardware from someone else, then the operational expenses are out of the window now. But we have the trade, we have to have the capital expenses, which is capex. So here you can see that you can pay on demand, you don't own any hardware, and again reduce total cost of ownership and operational expenses. Because I do not own something, so my total cost of ownership also comes down, as well as the operational expenses also comes down. Again, we have the benefits from massive economies of scale. So the prices are reduced as the AWS is more efficient due to large scale. As you can see that as more and more people will come into the cloud terminologies, they will use the different technologies, different hardwares, and the hardware are also getting cheaper now day by day. So that is why you can also benefit from massive economies of total scale. And you can stop guessing capacity. You can scale based on actual measured usage, and again, whatever you use, you pay only for that. We have increased speed and agility. The speed is very good. We can go very agile. And then we have to stop spending money running and maintaining the data center. So we do, again, this is related to the operational expenses. So we do not have to pay for running and maintaining the data centers, and we can go global in minutes. Here you can see that we do not have to do a lot of things. So again, if you want to travel something, either by owning a car, or you can go with the route sharing app. Then route sharing app is very easy. In just 5 minutes, you install an app and you are good to go to use a car. Whereas in owning a car, it was taking a lot of time. Okay, so the same thing is over here as well. You can go global in minutes. You can leverage the AWS global infrastructure. And one more thing which I wanted to talk over here. So let us say if you own a car and you have your car in some place and you travel to some other country. Over there, you cannot take your own car, but you have these services available in some other country as well. So you can rent a car over there as well. So this is kind of a global thing you have. You can use a car anywhere else, whereas it will be almost very difficult to take your car to some other place and then to use your car over there. Okay, so this is also global concept we have. And then let us look at the different problems which are solved by the cloud. Okay, so here we have flexibility. So the change resource type, you can change the resource type whenever you want. It is very cost effective. So we pay for whatever we use and we do not pay for whatever we do not use. And we have something called a scalability. We can accommodate larger loads by making hardware stronger or adding additional loads. We have electricity. We have the option to scale up and we have the option to scale out, scale in whenever it is needed. And we have high availability and fault tolerance because the cloud providers are making sure that the hardware is always available to me, the service is always available to me. So it is their responsibility to make sure that, although I have to pay more to make sure that everything is available. But yes, if I want to use that feature, I can use that. It is available by them. I do not have to make sure that how the hardwares are working fine, where they are, and how they are maintained, making sure everything. So I do not have to take care of that. And then finally, we have agility, which means that we can rapidly deploy, we can test, and we can launch our different software applications. Okay. And then finally, I will just left over here for the day. So here we have different cloud computing types. So we have infrastructure as a service, we have platform as a service, and we have software as a service. Okay. So this is the final topic we are going to discuss for the day. So let us understand what is SaaS, what is PaaS, and IaaS. Okay. So now if you consider this to be your AWS, okay. So first of all, if you consider this to be your AWS or any cloud service provider, so each AWS we are available in different regions. Okay. So the regions meaning that they can be available, they are available in, let us say, in US East region, they are available in London, they are available in Hyderabad, they are available in Bengaluru. So all these different locations are per se called as regions. Okay. If within the regions, they have something called as availability zones. Okay. Availability zones. Okay. So there could be n number of availability zones. Oh, sorry. Availability zones. Okay. So they are also, I mean, the short form for them is AZ. We can have multiple AZs available to us. There could be somewhere around 3 to 6 AZs available per region, and then each AZ will be a data center. Okay. So this is the hierarchy we have for the cloud providers. So let us say if we are talking about the AWS, first of all, we have this region. So this will be, let us say, your region. It could be any region. It could be Bangalore. It could be any region. Okay. So once we have the region, within this region, we have multiple AZs. Okay. So for now, let us consider that we have 3 AZs. So we have AZ. This is your AZ1 availability zone, and this is your AZ2, and then we have AZ3, and then these AZs are actually your data centers. Okay, all these are your data centers. So centers. So here you can see that the different hardwares, all the different hardware capabilities are available within your data centers. Okay. So as we had seen in the very initial phases as well, the data centers is a place where we are actually having all the hardware capabilities. So if you want to look at a specific data center, So let us say this is your one of the data center. If you focus on that, so let us say if you are talking about the EZ2 data center, then if you zoom into what is going on in your data center, then we will have a pool of resources available over here. So let us say we have 1000 GB of RAM available over here. We can have um, a lot of capabilities. Let us say we have 1000 core CPU they have maintained over here. It is not one component but multiple components, and then they have kept 1000 TB of hard disk is available over there. Okay, and again between the data center there will be the different data centers will be linked to each other, so there will be a link between them as well. This one, they will not be tightly coupled, they will be very loosely coupled to each other. And again, each data center is also capable of doing everything on its own. Okay, so this thing we have to mention. So this is how the things work. Okay, now, okay. So now here you can see that we have all the different, a very large pool of information or a very large pool of hardware components available within one AZ or within a data center of the cloud provider. Okay. So now here, what you want is that you as a user, if this is you as a user, and you have, let us see, you have created the, if you talk about AWS. So first of all, you have created the AWS account, and you are registered to a specific region. What you can do is that you can provision the hardware from this specific data center in your specific region. Okay. So here what you can do is if you as a user, if you have a a specific requirement, if you want 2 GB of RAM and then you want one core CPU, you have a very minimal requirement. Okay, you have one core CPU and you want 10 GB of hard disk. Okay, then what you can do is that you can provision this hardware from this pool of hardware which is available to them. So multiple users, some users can take, so here from here you have 2 GB of RAM, some users might be having 100 GB of RAM, some user might be asking 1 TB of RAM. I mean, there are a lot of different users who are using the same hardware capabilities. We are asking for one core, some user might be asking for 100 core, some might be asking for 200 core CPU, and so again for the hardware as well, hard disk, we want 10 GB of hard disk, some might need 100 GB of hard disk, and so on. So here you can see that multiple users are taking a chunk of whether it is processing power, whether it is storage, or whether it is the hardware storage or your RAM storage. So this is something, because this is happening at the hardware level and you are provisioning a hardware. So this is called as infrastructure as a service, because you are actually asking for an infrastructure. You're asking for a RAM, you're asking for a CPU, you're asking for a hard disk, you're asking for a network capabilities. So you are asking for an infrastructure, and that infrastructure is being available to you based on the service. You do not have to purchase it, you do not have to do the marketing, you do not have to do the research, you do not have to anything. You can directly register with AWS, associate to a specific region, and take whatever you need from your different data centers. Okay, okay, so this is the very most bottom layer we have within the cloud service provider, which is IaaS. Here we are provisioning the hardware. Okay, and after that, okay. So your IaaS has provided you with the hardware. Okay. And now the next step is, so here, if we read about the over in the PPT, so IaaS, they provide the building blocks for the cloud IT. Here they provide the networking, the computers, the data storage space. And we have got the highest level of flexibility, meaning that if tomorrow I want to scale up from 2 GB of RAM to 10 GB of RAM, I can easily provision from this large pool of RAM available. If I want to access more CPU cores, if I want more hardware, I can do it from here very easily. So we have the highest level of flexibility, and then we can easily parallel with the traditional on-premise IT solution. Then everything will remain very same. Everything is like as if it is what we were doing previously as well. So we have got the hardware, and now I want to host my website, or if I want to develop my website, then I need something called as platform as a service. Okay, so PaaS actually is a combination of your IaaS and PaaS. So this is your PaaS. So PaaS includes your IaaS. Okay, so let us say if you want to develop an app, in a specific language, or if you have some tool or technologies in your mind, then what you can do is that you can ask for a platform. So the platform is going to give you a platform or a place where you can develop your app, you can test your app, you can deploy your app, or you can use any IDE, you can use any testing tool, or all the tools, terminologies, IDEs, dependencies as well. So if you have some dependencies, all the things which you want to develop or deploy or test your app are all provided you as a part of this platform as a service. Okay. So anyhow, you do have the hardware, but as well you have all the software deployment and software development tools available to you so that you can develop a tool or you can deploy your tool in one place if as you please. Okay. So if I go to platform as a service, so it removes the need of your organization to manage the underlying infrastructure, and you can focus on the deployment and management of your applications. So you do not have to worry about where your hardware is, how it is being managed, how it is being procured. You just, as a developer, you use this platform as a service and you develop your app, you test your app, and you deploy your app. Everything is available to you. Okay. And then finally, we have something called as software as a service, where the software is provided to you as a bundled package. Okay. So if you look over here, the software as a service is a completed product that is run and managed by the service provider. So here you can very well see that if you look at any app, if you even look at RKS or Data Vision app, then the packaged software or the packaged tool is available to you, and then you do not have to actually worry about anything, which application it is developed on, how it is deployed over there, which hardware it is actually on, which we discussed in the case of Gmail and your Netflix application. The software is available to you and everything is being managed for you. Okay. So you don't, you as a user can go to the software or the service, and then you can use your service and you can focus on your usage, whereas you do not have to worry about where it is, how it is deployed, how it is managed. Everything is out of your thinking. Okay. One thing over here, so data warehouse is a software as a service offering. Okay. So now if you look at one more scenario, so here you can see one very important aspects over there. So if I go full screen, so here you can see that we have different services. So on-premise, here you can see that the blue boxes are actually managed by us, whereas the orange boxes are managed or it is being managed by someone else. Okay. So in the on-premise, you can see that the applications, if you go from bottom, so on your networking, your storage, your servers, virtualization, OS, middleware, runtime, data, and application all are managed, maintained by the one entity or your different cloud, different your organization itself. But if we talk about infrastructure as a service, in the infrastructure as a service, your networking, storage, servers, and virtualization are provided by a different vendor, and you take care of operating system, middleware, runtime, data, and application. And if you go one step further, if you go for platform as a service, over here, we just have to take care of developing an application and how the data is going to be stored and where the data is going to be stored. Whereas the runtime up till the networking, everything can be procured by somewhere else. And the software as a service, if you look at software as a service, over here, all the different layers, IT layers, are being managed and maintained by someone else. You as a user, you just come and access your service, and then you are good to go with that. And you do not have to worry about how everything has been managed and maintained. Okay. So that is it for today. If you have any questions, please feel free to ask and let me know if you have any questions. That is it from my side.